Now we are seeing properties of multiplication of whole numbers. So properties of multiplication. If let's say a and b are whole numbers, then their product a into b is also a whole number. So this is the basic. Based on that we derive the properties, or we just draw observations of the properties of multiplication. First is closure property. What it says: if a and b are two whole numbers, then their product a into b is also a whole number. What we have started saying, it derived to closure property. We just written it down again for clarification. So we can say this in other words: if we multiply two whole numbers, we get a whole number. So if we multiply two whole numbers, we get a whole number. That is a closure property. So it's a closed loop. We start with whole numbers, we get the whole numbers. So let's say we see this a into b, and we'll just verify is a into b is whole number or not, their product is whole number or not. So 8 into 9, that is 8 into 9, 72. Product is whole number, yes. Then 0 into 15, product is whole number, yes. 0 is the only whole number which is not natural. So this is closure property. Now commutative. This is V. Commutative property: the multiplication of whole number is commutative. Means, in other words, we can say that if a and b are two whole numbers, then a into b is equal to b into a. So a into b into a, and we have to verify whether a into b is equal to b into a. That is a question mark. So 8 into 9, 72. Then 9 into 8 is also 72. So yes, it's commutative, or we'll say 0 into 35. 0 into 35 is 0. 35 into 0 is 0. So this is commutative. Yes. Now multiplication by 0. What happens if we multiply a whole number by 0? Yes, this is a property. This can be feel as obvious, but this is a property. So if a is any whole number, then a into 0 is 0, or a into 0 or 0 into a is 0. So what it says, product of any whole number and 0 is always 0. We have seen that. Then next is existence of multiplicative identity. Existence of multiplicative identity. What it says, if a is a whole number, then a into 1 is equal to a, or 1 in that is 1 into a. In other words, product of whole number and 1 is the number itself. So let's say a into 1, that is 12 into 1 is 12, or 1 into a, that is 1 into 12 is 12. So a into 1 is equal to a into 1 is equal to 1 into a is equal to a, that number itself. That is existence of multiplicative identity. Then associativity. Associativity. If a, b and c are whole numbers, then a into b into c is equals to a into b into c. This is associative, means product of whole numbers is associative, means it does not change or the value of product does not change by changing order of multiplication. That means we do here a into b and here we do b into c. A into b brackets into c. So first a into brackets b into c. That doesn't change the value of the product. We'll see here. Let's say a, b, c. So 2, 3, 4. A into b into c. So 2 into 3 into 4 comes to 24, or A into B into C. So what is a 2 into 3 into 4? That is also 24. So A into B into C is equals to A into B into C. Yes, these are equal. That is associativity. Now next is distributivity of multiplication over addition. That is, if A, B, C are whole numbers, then A into B plus C is equals to A into B plus A into C, or B plus C into A is equal to B into A plus C into A. That is distributivity of multiplication. So in other words, multiplication of whole numbers distributes over their addition. We'll just take example A, B, C, that is 2, 3, 5, A into B plus C. So 2 into 3 plus 5, 5 plus 3, 8, 8 into 2, 16. Then A into B plus A into C. So which just changed the form, A into B, A into C. We distribute multiplication over addition. So 2 into 3 plus 2 into 3 plus 2 into 5 comes to 3 to 6. 5 tens are 5 twos are 10. So 10 plus 6, 16. So yes, so A into B plus C, that is equal to A into B plus A into C. These are equal. Yes, their products are equal, or their values equal. That's it.